Okay, today we're going to be taking a look at what is the meaning of these things. So we have an integral that's equal to 10 cubic feet. So what is the meaning of this? And that's what we're going to look at today. We have a little bit of information up here. It says that G is the rate that snow is removed from the driveway. And then it says F is the rate that snow accumulates on the driveway. So F is kind of like the rate in, you have snow accumulating, and G is kind of like the rate out. So snow is being removed from the driveway. We do have this amount function that has the starting amount of 0 plus all the changes. So you have to try to figure out what is the meaning of this. So one of the most important things you have to describe is the time. So I usually try to start with the time. You could say from t equals 0 to t equals 2 hours. So notice that's a time interval. It's not at a moment in time. Another way you could say it is you could say from midnight to 2 a.m. So if you read the story, if you're familiar with this question, it starts at midnight, and so t equals 2 is actually 2 a.m. Or even a third way that you could say it is you could say during the first 2 hours. Okay, next we got to pay attention to what f is, because we're doing the integral from 0 to 2 of f. So we're doing an accumulation of f. So we're adding up all of whatever f is. You'll notice f has units of cubic feet per hour, but when we do the integral, it's going to cancel one of the units of time from the bottom. So our answer will just be cubic feet. I want you to notice that f is the rate that snow accumulates. So then 10 cubic feet would just be the amount of snow that accumulated during that 2-hour period. So we're going to say from t equals 0 to t equals 2 hours, 10 cubic feet of snow accumulated on the driveway. And that's it. Notice we did not use G. So G is the rate that snow is removed from the driveway. So we're not talking about that. So we definitely do not want to say that that's the amount of snow on the driveway at time t equals 2 hours. That would be wrong. This is just the amount that was accumulating on the driveway. We're not considering the amount that was removed, and we're also not considering the starting amount. Okay, here's our second example. I want you to notice I don't have the actual r of t function written down in this example. And that's because we're really focusing on the concept here. Whatever the actual function is doesn't really matter today. It's really just the concept that's important here. So if you look up here, we were given r of t, which tells you the rate that the mosquitoes are changing. So we created the amount function. What they gave us was just the rate function. And we have to figure out, what does it mean when you say r of 5 is equal to -9 mosquitoes per day? So what does that mean? Well, the first thing we want to do is talk about time. That's how I prefer to do it. So this is at an exact moment in time. So this is when t is equal to 5 days. So that's how I'm going to start it off. When t is equal to 5 days, I'm saying that the amount of mosquitoes on the island is decreasing. Remember, if your derivative is negative, then your original function, which was the amount of mosquitoes, would be decreasing. So the negative basically means decreasing, and it's decreasing at a rate of 9 mosquitoes per day at that moment in time. So this is not an interval of time, this is at an exact moment of time. -9 mosquitoes per day is an instantaneous rate of change. It's how the amount of mosquitoes is changing at that moment in time. Now, there is another way you can write this. Instead of saying the word decreasing, you could say the word changing. But if you do that, then you're going to need the negative again. So you'd have to say changing at a rate of -9 mosquitoes per day. And that's it. That's the meaning of this. All right, for example 3, it says that F is the rate that people enter the auditorium. The units are people per hour. So we have to figure out what is the meaning of F prime of 2 is equal to 5 people per hour squared. Now I want to point out that F is already a rate. So F prime is the rate that is changing. So we almost have the word rate twice. It's the rate that a rate is changing. So this is going to be pretty tricky. Now for this example, we can just completely ignore the A. And the reason for that is because F prime describes F. It doesn't really describe A. So we can kind of ignore A, and I'm just going to erase it here. So now we're going to take a look at what F prime could be. Again, it's going to talk about F. And I always like to start all my examples with time. For this example, the time is clearly going to be 2. and the units are hours. So I'm going to say when t is equal to 2 hours, and that's how we're going to start it off. The next thing I want you to focus on is the fact that our derivative was positive. So that means that f would be increasing at this rate when t is equal to 2 hours. So I want to point out that I underlined what f was. So I'll fill that in later. Right now I'm just going to call all that stuff f. And so I'm going to start off by just saying that this is the rate that f is increasing at. And then my last step is just to replace f with what's underlined in red. So when t is equal to 2 hours, I'm saying f is increasing at a rate of 5 people per hour per hour. So even though f is this big, long, confusing thing, I've made the problem really easy by just calling it f right now. And again, I do need to explain the meaning of this, so my last step is just to replace f with all of this stuff. So I'm just going to replace f right here with all of that stuff, and then I'll basically be done. And the reason I'm doing it this way is it's a lot simpler to understand. Since f prime was positive, that means that f is increasing. And it's increasing at this rate right here, 5 people per hour squared. That's easy. But I can tell you that if you didn't use f, if instead you used all these words over here, I think you would confuse yourself. One of the weird things is you're going to end up seeing the word rate twice. And you might end up confusing yourself and second guessing yourself. So just don't do that. Do it the simple way, just call all that stuff f. And then after you do the easy description, just replace the f with whatever f was. There we go, I replaced the f with that red writing that you see right there. It says when t equals 2 hours, the rate that people enter the auditorium is increasing at a rate of 5 people per hour per hour. And I don't think there's any way you would have come up with that answer if you didn't do it the easy way that I talked about a second ago. The easy way would be to call all of this stuff just f. That's pretty easy, right? When t equals 2 hours, f is increasing at this rate. The reason we know f is increasing is because f prime talks about f. The reason we say increasing is because this derivative is positive. And the rate that we're talking about is simply just 5 people per hour squared. And we write it in a sentence, that's per hour per hour. So I highly recommend you using my technique where I just call all of this stuff f initially, and then later on I trade the f for whatever f is equal to. Because this is kind of a tough one, but you can make it easy if you use that technique that I just used. All right, let's go to the next example. Okay, again, they give us r of t. So they tell us in the problem that r of t, which has units of kilometers per hour, is the rate that cars travel along the road. So what would be the meaning of all of this stuff here? Well, one of the things I always say is pay attention to the units. The units kind of tell you what's going on here. And for this example, they ask you to first solve this. And so they don't give you this. You don't know that it's 10 kilometers for the answer. You have to plug it in a calculator, and you'll get 10 with your calculator, and you have to know that the units are kilometers. But again, if you pay attention to the units, when you do the integral of r, it's going to cancel one of the units of time from the bottom. And so that's how we know that the units for this is kilometers. And if we know that the units are kilometers, that kind of tells you what the meaning of this thing is. It means that you traveled 10 kilometers, and it would be during this time interval. All right, now let's go ahead and put that in a sentence. Again, we're trying to explain the meaning of this integral. I think it's best that we start with the time. You'll notice the units are hours. So it's going to be from t equals 0 to t equals 3 hours. Sometimes people say during the first 3 hours. There we go. It says from t equals 0 to t equals 3 hours. So that takes care of our time interval. We're going from 0 to 3. And our answer is 10 kilometers. So that's basically the distance that the car traveled. There we go. And that's pretty much it. You don't need to overcomplicate things. This one was pretty simple, pretty straightforward. Let's have a look at number 5. Okay, for number 5, we start with 2,500 cubic yards of sand on the beach. There is a rate that the sand is being added, and there's also a rate that the sand is being removed. For this example, all we care about is the R rate, because we're trying to explain the meaning of this, and we're not using the S. So let's take a closer look at what R of t is. It's the rate that sand is being removed. The units are cubic yards per hour. Remember, they do not give you the answer. So you start with just this right here, and you have to figure out the meaning of this. So you plug it in your calculator, and if you got 10 for your answer, how would you know what the units were? Well, remember, the units for r of t would be cubic yards per hour. So after doing the integral of r of t, we're going to cancel one of the units from the bottom. So our new units would be just cubic yards. And this kind of tells you what's going on there. We know that the r of t is about removing sand. And then we have an amount here, 10 cubic yards. So this seems pretty easy. It's just during this time interval, we must have removed this many cubic yards of sand. And that's it. Let's put that in a sentence. There we go. It says from t equals 0 to t equals 3 hours. So our lower bound was 0 and our upper bound was 3. So we're talking about the time interval from 0 to 3. And the units are hours. You can look everywhere. You're going to see all the units are hours. We got 10 cubic yards of sand. And the r function is the rate that we remove the sand. So the meaning of this would be that during this time interval, 10 cubic yards of sand was removed. And that's it. It doesn't need to be complicated. Keep it simple. Don't write anything extra, and don't confuse yourself. Okay, let's go ahead and look at number 6. For number 6, we're trying to find the meaning of this. Again, a lot of times they ask us to calculate it first, so we don't get this right here. We have to plug that in our calculator, and we also have to figure out what the units are on our own. So usually they give you this, and they ask you, what is the meaning of this? I want to point out something interesting. This is the first one that we've seen where they give you a starting amount plus, and then we have all the changes here. So this is looking like the total change theorem. Usually what this is this is the exact amount that you have at this time right here. That's usually what that is. We got to make sure that this time goes with this amount here. It doesn't have to be 0, but that time t equals 0 does have to match up with the 2500. Now, getting the 2200 is really easy. You just type it in your calculator. You're going to type all of this in your calculator, and you'll get 2200. But I do want to talk about how I got cubic yards for my units. Both S of t and R of t have units of cubic yards per hour, and we're doing the integral of those rates. So when you do the integral, it's going to cancel one of the units of time from the bottom. And that's how I'm getting cubic yards for my units for this example. This one also has cubic yards for units. This is the amount that you started with. You started with 2,500 cubic yards of sand on the beach. So that's the reason that our final answer is going to have cubic yards of sand. But again, this is the important thing right here. This is kind of telling you that it's probably the total change theorem. And what the total change theorem does is it tells you the exact amount that you have at this moment in time. Of course, this has to match this time here. So our time is 3, and the units are hours. So we're going to say when t is equal to 3 hours, and then we're going to say that there's this much sand on the beach at that exact moment in time. Okay, there we go. At time t equals 3 hours, there is exactly 10 cubic yards of sand on the beach. And that's it. I did say that I knew this was the total change theorem because it had the starting amount and then plus and then all the changes. That's exactly what the total change theorem is. And the total change theorem tells you exactly how much you have at a moment in time. It's kind of like an instantaneous amount. And that time would be this ending time here. So we're going to say when t is equal to 3 hours. Remember, this starting time can be any number. It just has to match up with this starting amount. You also have to be careful about this inside here. This needs to be the rate of change. And if there are 2 rates, you have to have both of them. So you'll notice that we have the rate that we're adding sand, and then minus, and then the rate that we're removing sand. Sometimes there's just one rate, but for this example, there are 2 rates. So we must include both of them. But that's pretty much it. This is our answer. Notice we always include time. We also include units every time, so make sure you have correct units. All right, let's go ahead and look at number 7. Okay, for number 7, it's a pretty easy one. We got to find f of 3 with our calculator. You plug it in and you get 253. We already know the units because those are given, cars per minute. And we also know what f means. It's the traffic flow at an intersection. Now, if they want me to explain the meaning of this, I always try to start with time. We can clearly see here that when t is equal to 3 minutes, there we go, at time t is equal to 3 minutes. Now I want you to know that f is a derivative. It's the derivative of the a function, and it's a positive number. So if you plug this in your calculator and you get 253, then you should notice that my derivative is positive, so that means that this is increasing. And so basically we can just say that a is increasing at this rate. Again, f is a prime, and we got a positive number, so that means that a is increasing at that rate. So we could write that down, that a is increasing at that rate. All right, there we go. And I usually like doing it this way. Whenever there's a big long description in there, you'll notice this underlined thing is a big long description. It says the amount of cars passing through an intersection. So that's what a of t is. And since that's such a long sentence, I originally write it down as just a of t. So it says at time t equals 3 minutes, a of t is increasing at this rate. And here's your rate. Then my final step is just to go back and trade a of t for what a of t is equal to. So let's go ahead and do that. There we go. There's our final answer. It says at time t equals 3 minutes, and I traded the a for the amount of cars passing through an intersection. So it says the amount of cars passing through an intersection is increasing at this rate, 253 cars per minute. And that's it. Okay, number 8, this is our last example. They want us to explain the meaning of f prime of 2, and usually they want us to find f prime of 2 first. So if you plug it in your calculator, you're going to get 5, and then you got to figure out what are the units. Well, if f is meters per hour, then f prime would be meters per hour squared. So you're getting an extra unit of time on the bottom. Now you'll notice the description for f is this big long thing here. So I'm just going to call it f for now. And since our derivative was 5, then we would say that f is increasing at this rate. You'll notice the units of time are hours, so it would be at the moment when t is equal to 2 hours. So let's go ahead and write that down. There we go. At time t equals 2 hours, f of t is increasing at a rate of 5 meters per hour squared. And again, when you have hours squared, we just write that as per hour per hour. But I'm writing all of this stuff as just f initially because it's easier to understand. And then again, my very last step would just be to trade f for all of that stuff. So let's go ahead and do that right now. Okay, there we go. We traded f for all of this red stuff here. So it used to say at time t equals 2 hours, f is increasing at a rate of 5 meters per hour squared. Now, after trading it, it says at time t equals 2 hours, the rate of the distance between the road and the edge of the water is increasing at a rate of 5 meters per hour squared. Now, if we tried to write that initially, we would have been so confused that we would have been lost and we wouldn't know what to do. So you want to try to make things simple. So initially, I'm saying that you should just write this as just an f, because that's pretty easy to understand. F is increasing at this rate. That's pretty easy. And then you go and you find the meaning of f, and you replace f with its meaning. And that's it.